I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will connect with the exponential functions, the logarithms. We'll prove the laws of logarithms. We'll prove properties of logarithms using simple concepts. And then apply these learnings to simplify the expressions. Let us explore with the student Abhinav and learn more from Anil Kumar channel. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now learn with Abhinav. Hi Abhinav, how are you doing?
I'm good. How are you?
Very good. So today, what do you want to learn?
More about laws of logs, and growth and decay.
Very good. So you know basics about logarithms, and what you have learned already is that log is inverse of exponential function. And since the exponential function is always positive and its range is greater than 0, domain being all real numbers, log being inverse, its domain is greater than 0 and range is all real numbers. Correct? You know that much, correct?
Yeah.
And now we look into the properties of logarithms. Let me share with you uh, a video from my YouTube channel. I think that will help us. So we have very simple videos on concepts of logarithms, small videos which give you correct information within no time. So can you see the screen?
Yeah.
Can you please read the very first, this, what is there on the screen?
Log base 1 equals 0.
So we are talking about the properties of logarithms in this particular video, and we have 4 properties listed there, right? Which are the basics to begin with. The very first one is log to the base b of 1 is 0. Log to the base b of 1 is 0, right? It makes sense. Since anything to the power of 0 is 1, right? So if you rewrite this equation in exponential form, what do you get? You'll get 1 is equal to b to the power of 0. Is that okay? And you know, anything to the power of 0 is 1. So that side is correct. Is that correct? The second one, again, if I write in exponential form, log to the base b of b is 1, I could write like this. B is equal to b to the power of 1. This is how we write logarithmic function in exponential form, correct? And you see that this property is true because b equals to b to the power of 1. Anything to the power of 1 is the base itself. Correct?
Yeah.
Now the next property here is log to the base b of x is equals to x. If I write it in exponential form, I get b to the power of x is taking this on this side, b to the power of x, which is also true, correct?
Yeah.
Which is also true. Now the last property is slightly more tricky, which is b to the power of log to the power of bx equals to x. That is the property which we have to look into, correct?
Yeah.
Now, how do you correlate with this? Now, let us say if it is not x, it has to be something else, right? So from there, we could actually correlate. Is that correct?
Yeah.
Or what we could do here is, whenever you have a exponential function, you can take log and then figure it out. Is that correct? So we
Yeah.
could actually solve this by taking log, right? So we will see that how to solve that. But here, what we did was, we have shown that left hand side is equal to right hand side when we convert log function into an exponential function, right?
Yeah.
Easily we could correlate. We will see how do we prove it within no time, right? So second part is to prove. So let me move this video slightly ahead to show you the proof for all of them. All the proofs are actually on one sheet itself, one page, and therefore it is not very difficult to see them all right there. So let's move forward. Almost at
Okay.
the end, you will see all the proofs on the page itself. The very first one, which we just showed, log to the base b of 1 equals to 0, it basically means what? Just as I was saying, write this into the exponential form to get an idea of what this is, right?
Yeah.
Now, let us say, how do we prove it? We could also prove it in another fashion, and that is, let log to the base b of 1 be x. Let us say we don't know whether it is 0 or not. Let it be x, correct?
Yeah.
If it is x, then 1 is equals to b to the power of x. And from there, it is very clear that x should be 0, because to get 1, b to the power of 0 is 1. Is that clear to you? So you could use this part of the proof to prove the first statement, correct?
Yeah.
Similarly, for the next statement, we are saying that log to the base b is equals to 1. We don't know, let it be x, any other quantity, correct?
Yeah.
In that case, b is equals to b to the power of x, correct? And these two things are true only if x is equal to 1. And therefore, we should have log to the base b of b as 1. Is that correct?
Yeah.
So we have shown the proof. Next, log to the base b of b to the power of x is x. How do we prove that? In that case, we will make a substitution. And let the substitution be log to the base b of b to the power of x, that is left hand side, let it be equal to y. Is that okay?
Yeah.
In that case, writing this in exponential form, b to the power of x is b to the power of y. And that is true only if x is equal to y.
Yeah.
That means y is x. So we have shown that log to the base b of b to the power of x is x, correct? Not
Yeah.
anything else. Y became equal to x. The last part is very similar to the one we just did. B to the power of log to the power of log base b of x should be equal to x. So we are saying, let it be b to the power of t something, correct? We don't know what this is. Let it be b to the power of some number t, right?
Yeah.
In that case, the exponent should be same. That means log to the base b of x should be equal to t, correct?
Yeah.
If you write this in exponential form, you get x is equals to b to the power of t. You get x is b to the power of t. So that means this b of to the power of t is x, correct?
Yeah.
So we have shown that b to the power of log the base b of x is also x. Is that clear to you?
Yeah.
So this is a very simple and very effective proof for the basic properties of logarithms. I will like you to write down these 4 properties on one page. Is that clear?
Yeah.
Okay. So have you written? Then we'll move forward and learn about more properties of logarithms. But we can use these properties to solve some logarithms.
Okay. Yeah, I wrote them down.
Very good. Exponents you remember. You can copy these properties. We'll prove them now.
Okay.
And what are we going to use is something like this. If you have b to the power of, let us say, s, or let's say t, times b to the power of s, when you multiply with the same base, you get what? B to the power of t plus s, right?
Yeah.
If you have b to the power of t to the power of s, you get what? B to the power of t
Yeah.
times s.
Yeah.
And if you are dividing them, right, then it is b to the power of t minus s, right? So these are
Yeah.
the exponential properties which you already know. Since logarithms are inverse of exponential functions, they show similar behavior, correct? So we
Yeah.
have these properties of logarithms, that is, log to the base b of product of two x and y in this case should be equal to sum of individual logs. Do you see that?
Yeah.
But when it is written in the quotient form, x over w, then it is a difference. And when it is written in the power form, then it is r log to the base b of x, correct?
Yeah.
How do we prove these properties? So one page, you have all the stuff here. So have a look at it. So that is a simple proof. So what we are trying to do in this case, use the properties of exponents to prove the properties of logarithms. So the very first one is log to the base b of x times w. So remember, product of x and w should be positive, right? Because log is defined for positive non-zero numbers, correct?
Yeah.
So, okay. So what we are doing here is a substitution. Let x be b to the power of s. So we are making a substitution here, right? Our substitution is log to the base b of x, let it be s, and log to the base b of w be t. We'll make this substitution to prove all of them. Can you write this in exponent form? Yes, x is equal to b to the power of s, and w is b to the power of t, correct?
Yeah.
So this box shows here how you could write individual logarithm as an exponent. Then it becomes easy, right? So now the equation left hand side, the very first one, is log to the base b of x times w. It really means x and w are what? X and w are b to the power of s and b to the power of t, correct?
Yeah.
So you have b to the power of s and b to the power of t. When you multiply them, you basically add the exponents as shown, right?
Yeah.
And you learn property that log to the base b of b to the power of x is just x. You remember the fourth property in the previous example?
Yeah.
Look into your set of properties, correct?
Yeah.
Third or fourth property, right? So there were four properties which we did last time. So third property. So that is this is x plus t. And what is s? And what is t? It is the sum of logarithms. You get the idea.
Yeah.
So very simple to prove just by this substitution written on the right hand top corner. Log to the base b of x is s and log to the base b of w is t. Written in exponent form, x equals to b to the power of s and w equals to b to the power of t. You can actually prove all of them, right? So, Abhinav, I'll request you to take this as an exercise. However, the proof is right before you, correct?
Yeah.
So, similar properties. We are now second to b to the power of s divided by b to the power of t. That means b to the power of s minus t. And that is s minus t means difference of these two logarithms. So, you have shown that. And when it is power of power, it gets multiplied. You get b to the power of sr. So, sr from the property number 4, which we learned in the last page, it is equals to SR, and S and R is the product of the two, correct?
Yeah.
So you get R times log to the base B of X. Is that clear to you?
Yeah.
So now make a note of all these properties, and we will take a few questions based on simplifying logarithmic expressions or writing them as one logarithm when we are given some expression, okay?
Okay.
So here is the question for you. Can you pause the video here? Can you please write this as a single logarithm? Tell me what is your answer. Okay. So in this case, let me stop. So this can be written as log log to the base b of x square, right? That we are doing the reverse of the property which you wrote just now. You remember? If you write log to the base b of x square, you write 2 times log to the base b of x, right?
Yeah.
No, because we have to combine them. We are doing the reverse process. And this can be written as minus log to the base b of y cube. Is that okay?
Okay.
Plus log to the base b of w to the power of 5. Is that clear to you?
Yeah.
Now, when you subtract, it is division. So it will be log to the base b of x square over y cube, and you're going to multiply by w to the power of 5. Do you see that?
Okay. Yeah.
That is how you will simplify this as one expression. So in this question, which is slightly difficult from the normal questions, that is, we have to do a backward calculation to write this in the form as shown here, and then we solve it. Is that clear to you?
Yeah. Yeah. All over minus log to the base of b radical w.
No minus. See, as written on the screen, you see that that becomes division, right? So log to the base b of all this. You see that? Of all this, correct? So
Yeah.
that is what you will get. So whenever it is plus, it will be multiplied. When minus, it will be divided. And important thing is, whenever I write a log to the base b of x, it basically means log to the base b of x to the power of a. Is that okay?
Yeah.
Then you have the same base and you can do the needful. Is that clear to you? Now that brings me to another very important question, which I'm going to share with you now. So let me just search for simplify logarithms.
Wait, so on that last question, you just canceled out all the logs?
No, log remains. We never cancelled the log. Log remains and everything comes in the base. Is it okay?
But on the denominator, it doesn't have a log. It just says square root of w when you wrote it.
Yeah, because it is like, let me just show you.
Yeah.
Do you see this written?
Yeah.
Log to the base b of all this. Like all this is one part. Is it okay? That is your answer.
Oh, yeah. Okay, I got it. Yeah.
Yeah. Log is there. But the argument is product of the two and quotient with w square root. Is that okay?
Yeah. Okay, I got it now.
Right. So let's see more log simplified. Challenge. Let's see some other questions based on this kind of laws, right?
Okay.
Now you have not learned all the properties of logarithms, and therefore there could be some difficulty, but here is a good question. Let's look into this question. How do we find solution of logarithmic equation? Okay.
Okay.
So I'd like you to explore some more examples. I'll share with you some difficult questions based on this later.
Okay.
So there are many questions in this particular list. Now here, we'll talk about a very important property before moving forward, and that is called change of base property.
Okay.
And then we'll take up these questions, correct? So these questions have different base to work with. So earlier property, which we discussed, the base was b for all of them. You could easily add, multiply, divide, and get your result, correct? How?
Yeah.
It is not necessary that always you get the same base. Many challenging questions will have different base. So here we have a question. Can you please read question number 1?
Okay. Solve log base g of x minus
9,
log.
9. Base 9 of x
Solve
minus,
log.
yeah.
Yeah. Solve log base 9 of x minus log base 3 of x equals 0.
So their base are different. Since their base are different, we cannot actually write x over x. You get the idea? Because the base is 3 and base is 9. So first step is to write these logs with the same base. And for that, we use a change of base formula. You see this change of base formula?
Yeah.
Log to the base a of x can be written with base b as equal to log to the base b of x divided by log to the base b of a. Do you see that part?
Yeah.
So this is called change of base formula. We need to apply the change of base formula to solve such questions because we need the same base. You get the idea?
Yeah.
So let us see. How do we change base from 9 to 3? So I'll just do it and show you here. So we have log to the base, we have log to the base 9 of x, right?
Yeah.
Using the change of base formula, I could write this as a ratio of log to the base. We want it to be 3, right?
Yeah.
3 of x divided by log to the base 3 of 9. Is it okay?
Yeah.
Now what is denominator? Log to the base 3 of 9 is how much? Can you tell me?
2.
2. Because 9 is 3 squared. So that
Yeah.
gives me 2. So I could actually replace first term in this equation is log to the base 3 of x, half of that. Is that clear?
Yeah.
So half of that, right? So that gives me that now the equation could be written as log to the base 3 of half means square root of x, correct?
Yeah.
Do you see that? So I
Yeah.
have this particular function as log to the base 3 of square root of x minus log to the base 3 of x. It means over x, correct?
Yeah.
Equals to 0. Now you can write this as an exponential function. 3 to the power of 0 is square root x over x, correct?
Yeah.
Square root x over x is equals to 3 to the power of 0, which is 1.
Yeah.
So the x value has to be 1 because 1 over 1 is 1, right? That
How
means
did
the square root of x is equals to x, right?
Yeah.
So you get x equals to 1
How did you get log of base 3 radical x? But how did you get radical x over x?
because there is minus in between.
Oh yeah. Okay. Yeah.
So
I got it.
minus means you'll divide, right? Square root x by x. And that is equals to 3 to the power of 0, which is 1. So that
Yeah.
means square root x is x. And square root x is x only for x equals to 1. Also remember that the domain in this case is that x should be greater than 0, right?
Yeah.
So that is very important. So do you understand the idea of how do we solve such an equation? Can you attempt
Yeah.
the second question now?
Okay.
What will you do? Tell me.
Right. I changed log 4 of x.
That is better.
Yeah.
So
And
you wrote log to the base 4 of x as equal to log to the base 2 of x divided by log to the base 2 of 4, right?
and
Which
I
is
got 1/2 log base 2 of x.
x. 1/2 means square root, right?
Yeah.
So that was with minus. So what do you get here when you combine the terms? You get log to the base 2 of x plus 1 divided by square root of x, and that is equal to 1, correct?
Yeah.
Then you'll write it in exponential form. So 2 to the power of 1 is 2, right?
Yeah.
Which is, so I'll write 2 to the power of 1 as 2. And when you take the square root on the other side, it becomes 2 square root x. Is it okay?
Yeah.
Now you have to solve this radical equation. Remember that the value of x is greater than 0. Is it okay? Not great, because this equation gives you greater than minus 1. But that will not work for here. So x is greater than 0 is your domain of this function, correct?
Yeah.
Now to solve this equation, what are you going to do? You have to square both sides. You know x is positive greater than 0, right?
Yeah.
And both the terms, you just square both sides. and then you have to solve for it. So slightly longer question. It looks simple, but I hope you get an idea of how tricky the questions could be, right?
Yeah.
So take this as a homework.
Okay.
Let's move forward. So this is a very beautiful video, which is about 10 minutes long, but it is packed with questions, right? So let's take up more questions. So you understand the change of base formula which we did. So here we have neatly written down the solution of first question, right, which we just solved, right?
Yeah.
And then we'll take up the solution of the second one. So basically, as you did, we are showing that the second term, log to the base 4 of x, has to be written as log to the base 2, and that's what you get. And now you have to solve this particular equation. So in this particular case, when you do it, then as shown here, what we did was in the logarithm itself, we multiplied by 2. Did you see this part? Look at the solution. In my solution earlier, we squared later, correct?
Yeah.
Here, what we did is we just multiplied by 2 all the terms and we made this square rather than square root. It is easier to work with squares than with square roots. You get the idea?
Yeah.
So here is a good step. As you can see, we squared. I mean, we multiplied every term with 2. So we get 2 log to the base 2 of x plus 1 minus log to the base 2 of x equals to 2. We already did this part, right? And then we are writing this as x plus 1 whole square over x is equal to 2, and 2 square, which is 4, we'll do further and get the solution. Is that clear to you?
Yeah.
Do you see the solution now?
Yeah.
Extremely important question from test point of view. Okay,
Okay.
let's search some more. So there are many like this. Okay, let's look into this question. Very different kind of a question here,
Okay.
just to give you a variety of solving simple logarithmic equations. Okay, now we are using a lot of roots here. Radical function, log to the fifth root of x squared minus 15x equals to 2 over 5. So how will you do this? When we write log, it means it is to the base 10, correct?
Yeah.
So if you want to write this as an exponential equation, how will you write?
Okay. Log base 10 of 5.
10 to the power of 2 over 5, yes. Or
Yeah.
you could just rearrange it, right?
Yeah.
You could rearrange, bring 5 here, right? So you could write this as 5 log fifth root of x squared minus 15x equals to 2. Does it make sense to you?
So you just multiplied it. Oh yeah, because 5 is the denominator, you just multiply it by 5.
And then this will cancel that fifth root, right? So we get on the left side log of x squared minus 15x. Is it equals to 2? Does it make sense?
Yeah.
And then we'll write this in exponential form, which is x squared minus 15x equals to 10 to the power of 2, which is 100. So you have an equation which is x squared minus 15x minus 100 equals to 0. Quadratic equation to solve, right?
Yeah.
You can always solve this equation, write down the answer. Now, another question here is, what is the domain of this function? Can you tell me the domain of this function?
It has to be greater than 0.
So x squared minus 15x has to be greater than 0. So you could factor, you get x times x minus 15 greater than 0, correct? So that is a parabola with two x-intercepts, right? Which are at 0 and 15.
Yeah.
So everything in between. Do you see that? So your domain is that the x value is between 0 and 15. You get the idea?
Yeah.
So when you solve this logarithmic equation, you have to be very careful that the domain has to be between 0 and 15. Anything beyond this is not a part of solution. Does it make sense?
Yeah. What do we do with the 100 then?
So you just factor. X squared minus 15x minus 100 equals to 0, right? 20
Okay.
times 5 can work. So I'll factor this, right? You get the idea?
Yeah.
So factor this. Let me just remove and then rewrite. So let me rewrite the solution here for you. So we will first step will do 5 times log of fifth root of x square minus 15x equals to 2. It is a very difficult question. Abhinav, it looks simple now, but it's a very difficult question, okay? Challenge questions. So this means log to the fifth root of x squared minus 15x to the power of 5, right?
Yeah.
Equals to 2, which is basically log of x squared minus 15x equals to 2. Is it okay?
Yeah.
So now write exponential form, which is x squared minus 15x equals to 10 to the power of 2, which is 100, right?
Yeah.
Bring it on the left side to get x squared minus 15x minus 100 equals to 0. 100 is product of 20 and 5.
Yeah.
So we can factor this as x minus 20 times x plus 5 equals to 0. Is it okay?
Yeah.
So you can have two solutions. One is x equals to 20 and the other is x equals to minus 5. However, what did you learn? When we sketched this particular function, what was our domain? Our value was x times, I'm just writing in factored form, it's easy, right? X minus 15. That should be greater than 0. Is it okay?
Yeah.
So when you draw this graph, let me sketch this graph here. Then we have a 0 at x and 0 at 15. So our graph for this function is kind of like this. Correct?
Yeah.
We want positive value. That means we are looking for answers which are on the left side of 0 and on right side of 15. Correct?
Yeah.
Because this is greater than 0. So the positive part of the parabola.
Yeah.
And therefore, both the answers fit. So we have two answers for this particular question. You get the idea?
Yeah.
Minus 5 will make it positive and 20 also will make it positive. So we have two solutions for this particular equation. You get the idea?
Yeah. Okay. Also, on the right side of the equation, how did you get 100?
Okay, log to the base 10. So I wrote it in exponential form. 10 to the power of 2 is
Oh, yeah.
inside argument, which is, so writing logarithmic function as an exponential function is integral part of solving logarithmic or exponential equation. Is that okay?
Yeah.
Interchange their form and then you solve it.
Okay. Yeah, I got it.
Got it? So make a
Yeah.
good note of this question. Very beautiful question.
Okay.
So let's search for more and see if we have some more good challenge questions for you here. Okay. Now this is wonderful. So here is a challenge question which I'm not going to answer. Oh, it's already answered here. Very good. I'd like you to copy the question, please.
Okay.
It's a multiple choice question where you unfortunately see the solution first. Okay, so let me just go back to the question. Right? Yeah, this is better. Here is the question, right? Given that a to the power of x is equal to b to the power of y and ab to the power of xy, so these three things are equal. Can you see the screen properly?
Yeah.
Then which of the following equations is true? We are given 5 options.
Okay.
One of them is true in this case. How will you solve such a question? A to the power of x equals to b to the power of y equals to ab to the power of xy. It is a challenge question which has appeared in Olympiad type of competitive exam. Is it okay? This is not an easy
Yeah.
question. In fact, Senior Math Challenge UK. Actually, it came in Senior Math Challenge UK. So, have you copied the question?
No, I'm still doing it.
Okay, copy the question and then try to answer. Otherwise, look into the solution. And if you don't understand, you can always ask me. Correct?
Yeah.
Because solution is also not easy. It's very tricky solution. So in my channel, you can get, just type the word challenge or test questions. You'll get the whole test paper on logarithms, correct?
Yeah.
Let me do that for you. Logarithms, let's remove the word challenge and we write test. So we'll take questions from previous test papers now.
Okay.
Here is the test paper. So this is one of the beautiful test papers, one of the toughest on logarithms, which you will see, actually speaking, not joking. The student is a very bright student, and like, we should have all my students, right? So 99.2% marks. Do you see that?
Yeah.
Good. So this is ideal test paper for you, Abhinav. All the questions, since it is 99.2, have been correctly solved, so I don't really have to explain you much. You have the solutions right there, right?
Yeah.
So when you move through the test paper, as you've seen, the confidence of the student written in ink, right?
Yeah.
So here we have many questions based on logarithms. If you do this exercise, I can bet that you can answer 90% of the questions in any of your books.
Okay.
These questions are really difficult, right? So as you can see, to begin with, question number 1 itself is very difficult, right? More difficult than many of the questions which we did, right? Do you see part D? Can you please read part D?
Okay.
We did that, right? Writing at a simple form, correct?
Yeah.
Same base, but part
Log.
C, yeah. Have a look.
Okay. So part D. So log to the base of y.
4. Those bases are 4. So it is simpler because you have the same base, which is 4. So log to the base 4 of 3 plus half log to the base 4 of 8 minus 1 over 3 log to the base 4 of 8. You just need to simplify and write this as one logarithm. However, question number 1C has different base, correct? Log to the base 5 of 4th root of 125 plus log to the base 4 of 1 over 256, correct? You have to write with the same base. Okay?
Okay.
Now, let me just show you the test paper. So these are more questions on simplifying logarithms, which look very difficult than what we have already seen, right?
Yeah.
And then followed by question number 3, where you see exponential equation with different base. 3b is 6 to the power of 2x minus 3 equals to 10 to the power of 1 minus 3x. How will you solve this equation? You have to use the logarithms on both the sides and then solve this equation. Is it okay?
Yeah.
So I like you to look into this example. Even question number 2 is very tough. So we're just talking about few questions. There are more than 10 questions in this test paper. So to begin with, I mean, that is just a warm up, right?
Yeah.
Which is kind of difficult at this stage. So if you move forward, we are communication questions. And these communication questions have been combined with transformation. So the very first one is rewrite y equals to log to the base 8 of 64 over x as a transformation of the base function. Now, when we say base function, we are using base as log to the base 2. So in this particular case, you have to write the function with base 2 first and then explain the transformation.
Okay.
As done in this particular question. And part E is to describe the transformation that takes the graph of the base function to that of the transform function. So once you write that in that form which is shown, y equals to 1/3 of log to the base 2 of 64 over x. And then we have this equation here, right? Half of log to the base 2 of 64 minus log to the base 2 of x. You can see log to the base 2 of 64 is a constant. Minus log to the base 2 of x means a reflection, correct?
Yeah.
On the x-axis. And that is how you could actually explain this particular transformation. Is that clear to you?
Yeah.
This question, these are application questions. There are many of them in this particular video with thinking and application questions. So once you are done with your chapter on logarithms, you can actually get into this test paper on logarithms.
Okay.
Just a 2-minute test paper for you, which will give you one of the best questions you can see in any test on logarithms. Okay?
Okay.
Right. So let's see some more which are simpler than this. Let me just search. So as you've seen, there are many test papers. MCR3U is a grade 11 curriculum here in Ontario, Canada, from where I picked up few questions. Now, have you done inverse of functions so far? Not yet.
Hmm?
Have you done inverse of functions?
No.
Not yet. So as you know, log is an inverse function of exponential function. Natural log is inverse of e to the power of x. So this is based on e to the power of x and natural log, which we'll skip for today. And those are the transformations which we'll skip for today. Let's focus on more evaluating and simplifying logarithms. Is it okay?
Yeah.
Correct. So let's go back to basics. So here, this is the last video which I'm sharing with you. We'll have a couple of questions where we could write logarithms as a one function and then solve the equation. So there are two parts to this. So, okay. When I write natural log, ln means base is e, okay? Earlier we were writing log where the base is 10.
Yeah.
Here the base is e.
So it'd be log base
to the base e. Yeah. Yeah. That is what it means. Minus 1 whole square equals to 4. Correct?
Okay.
So when you want to rearrange it, you can square root. When you square root, so 4 will be plus and minus 2. So remember, when you solve this part, question 1, you have to write ln x minus 1 equals to plus 2, one equation, and minus 2, the other equation. Because log range could be any number, correct?
Yeah.
So that is how you have to solve the first question. For the second question, how will you solve it? Let's try.
Okay.
So the first one, we have squared there. So that means ln x minus 1 equals to plus or minus square root of 4, right? Which is equal to plus or minus 2, correct?
Yeah.
So ln x minus 1, so you'll bring 1 to the right side. So you'll say ln x equals to 1 plus minus 2, which is either it could be 3 or it could be 1 minus 2, which is minus 1, correct?
Yeah.
ln is to the base e, and therefore we get two solutions. One is x is equals to e to the power of 3, and the other one is x is equals to e to the power of minus 1, which means 1 over e. Is that okay?
Yeah.
So that is how we will solve this question. Students sometimes make a mistake of not using plus and minus. So you have to be very careful.
Okay.
Question number 2. 3 ln 2x plus 1 equals to 15. So we'll first divide by 3. So we get ln 2x plus 1 equals to 15 divided by 3, which is 5. No problem?
Yeah.
Then 2x plus 1 is equal to what? E to the power of 5, correct?
Yeah.
2x is equal to e to the power of 5 minus 1, and x is e to the power of 5 minus 1 divided by 2. Done? Simple? So it might look very difficult, but it is not so difficult, correct?
Yeah.
Good. Next question. So these are practical questions which you see. Question number 3. ln x square minus 7x plus 13 equals to 0. Tell me the first step. How will you write this equation in exponential form?
Okay.
Tell me.
X squared minus 7x plus 13 equals e to the power of 0, which
And
would
e to the
be
power of 0 is 1, right?
yeah.
Simple. And now bring them together. So you get x squared minus 7x plus 13 minus 1 equals to 0. So we have x squared minus 7x plus 12 equals to 0. And now 4 times 3 is 12, right? So you get x minus 4 times x minus 3 equals to 0. X equals to 4 and x equals to 3 is your solution. Is that clear to you?
Yeah.
You got the flow, right?
Yeah.
Beautiful. So that is how we are going to solve our questions. Last question for you now. Can you tell me how will you solve question number 4?
Okay, 1 second. Couldn't you start to divide by 2 because it has 2 ln?
Don't divide by 2, but write like this. That part could be written as an exponent. So avoid square roots.
Okay.
So you will combine the expression on the left hand side and write this as a single logarithm just as I have written.
Okay.
Equal to 0 means e to the power of 0 means 1, right?
Yeah.
So you get 4 minus 2x times 9 minus 3x equals to x plus 1 whole square. Is it okay?
Yeah.
Now you can expand, simplify, do everything, and then figure it out. Most important part here is remember one thing, that when you work with logarithms, you could have extraneous roots, right? So let me write this on the top. Means when you solve this equation, you might get a couple of solutions. You have to check. Put the value back in the equation and check. Does it give you the right answer? Left side
Okay.
equals to right side? Because your value may not be in the domain of the function, correct? What is the domain of this function? See, 4 minus 2x, 9 minus 3x, x plus 1. You have to first find the domain of the function, right?
Yeah.
Only those values which are in the domain of the function will fit in. So that is another very important part of solving logarithmic equations. So find the domain. So for example, 4 minus 2x means what? 4 minus 2x should be greater than 0, right? That means
Yeah.
4 should be greater than 2x or 2 should be greater than x, right? So we have that x is less than 2, right?
Yeah.
So I have one value. I'm saying that x is less than 2, where this value is at 2. Now look at the second part, 9 minus 3x, right? So we have 9 minus 3x, that should be greater than 0. So when you bring this on the right hand side, 9 is greater than 3x. So again, we get 3, right? So 3 is greater than x. So that means x is less than 3. So this gives you that x is less than 3, right?
Yeah.
Now the third part, x plus 1. X plus 1 greater than 0 means x is greater than minus 1. So this is minus 1 for me, and greater than minus 1 means all this, right?
Yeah.
What is the common interval? That is the domain.
Yeah.
So the domain of this function is between minus 1 and 2. Do you understand?
Yeah.
So your answer can only be between minus 1 and 2. Other answers are extraneous.
Why couldn't it be 3? 3 is also common though, right?
No, not in all the three, correct?
Oh, yeah, yeah, okay. I get
Not
it.
in all the three. If I have a value which is 2.5, in that case, my first equation doesn't work.
Yeah.
It's a very important thing from inequalities. So we have also solved inequality. So in today's lesson, you have not only learned logarithms, always the question on logarithm is combined with so many other principles because this is normally the last chapter of the book, correct?
Yeah.
When you read functions, right? So at this stage, you should be ready with all variety. So I'm stopping to share this and I'd like you to summarize today's learnings. Abhinav, what did you learn today? Can you summarize, please?
So we learned the different properties of logarithms and how to convert exponential functions into logarithms and vice versa. And we did other questions based on the properties of the logs and converting them into different forms and to solve them.
Perfect. And we took previous years of past test paper questions to work on so that we really understand how do we apply our learnings to solve examination style questions. You get the idea. Plus many videos which I shared with you and we did not solve mainly because you are not quite ready. So once you practice, then you take up those challenge test papers and solve them to gain more confidence. Correct?
Yeah.
So here we are going to end the class. Thank you and all the best. Bye.
Bye.